Hello students and welcome back to my channel. This is my third video in continuation with the remaining two videos. We are basically discussing questions which were asked on 27th of January 2024 JEE mains. So without wasting time, let us continue students. So here comes the 8th question. You can see a train is moving with the speed of 12 meters per second on rails which are 1.5 meters apart to negotiate a curve of radius 400 meters. The height by which the outer rail should be raised with respect to the inner rail. So student, this is based on banking of curved tracks. Banking of curved tracks. As you know, as compared to the inner rail, okay, as compared to the inner rail, the outer rail has to be slightly elevated. Okay, so this ensures the avoiding of friction. Basically, this ensures the avoiding of friction during the negotiation of curved tracks. So as you know, based on that, if this is the banking angle, so tan of banking angle is equal to V square by Rg. This is the formula you can see. I hope you are aware of this formula. So just it needs to be substituted here, and here tan theta will be h by the rail separation is 1.5 meters. You can take tan theta itself as sin theta. So we'll equate this to sin theta, which is h by 1.5 meter. Okay. Right. So here just substituting the values, V is given as 12 meters per second. So 12 into 12 divided by radius of curvature is 400 meters. 400 into G is 10. So let us, since the options are in centimeters, so we'll convert this into centimeters. So 150 centimeters and H. So just see how it gets cancelled. Okay. So 1 0 gets cancelled this way here. 4 3s are 12, 4 1s are, so 100. Then you have again 5 3s are 15, 5 20s are. Then again 2 10s are, 2 6s are. Okay. So we have 3 3s are 9, 9 6 are, 54 by 10. So 54 by 10, that is 5.4 cm. So this is the correct answer. Moving to the next question, students. Question number 9. A body of mass 1000 kg is moving horizontally with a velocity of this much. If 200 kg extra mass is added, the final velocity will be. This question is based on simply the principle of conservation of linear momentum. So conservation of linear momentum simply states that in the absence of external forces, the linear momentum of a system remains conserved. So as you can see, initially a 1000 kg mass was moving with a speed of 6 meters per second, and then an additional 200 kg was put gently upwards, and we have to find the final velocity. So initial momentum is equal to final momentum. You can see all this happened without the external interference of any force. So we have 1000 kg into 6 meters per second is equal to 1200 kg into V. So this will be 1200, as you can see, 1000 plus 200. So we are proceeding in SI units completely. So no problem. So this will be 6 2s. So V is equal to 10 by 2, that is 5 meters per second. So 5 is the correct answer. Okay. Then moving to the next question, question number 10. Two bodies of masses 4 gram and 25 gram are moving with equal kinetic energies. The ratio of magnitude of linear momentum is. Now students, see, we have to find the magnitude of linear momentum, ratio of magnitude of linear momentum, and we have been informed that the kinetic energies are same and also their masses. We have been informed about their masses. So the most appropriate formula to this will be this. Momentum is given by under root twice mass into kinetic energy. Now since the kinetic energy is same, so we can write momentum is directly proportional to the square root of masses. So we have P1 by P2 is equal to under root M1 by M2. What is M1? M1 is 4 grams. So 4 and M2 is 25 gram. Gram gets cancelled, so not a problem. So 2:5 is the correct answer. Moving to the next question, students. Question number 11. A ball suspended by a thread swings in a vertical plane so that its magnitude of acceleration in the extreme position and lowest position are equal. The angle theta of the thread deflection in the extreme position will be. This is very interesting question, student. We have to be very clear regarding the concepts of circular dynamics, okay, laws of circular dynamics. So law of circular dynamics simply states that the net acceleration towards the center will be equal to the centripetal acceleration. Okay. So now let us draw the diagram. So diagram is something like this probably. This is the extreme position, this angle is theta. Okay. And as it comes down, you have this. So here it is given that the acceleration here at, let us say, position 1 and the acceleration at position 2 are same in magnitude. So since the body stops here at the extreme position, so we can say that the only acceleration acting is g sine theta, because there is no, this force will balance, there is no net force in the radial direction here. Okay, students. So the only acceleration acting is the tangential component of acceleration due to gravity. Whereas coming to this point, you have, let us say it gains a speed of v, so it will have a radial acceleration here because it is moving. Okay, students. So that radial acceleration will be v square by L, where L is the length of the simple pendulum. Is it clear, students? V square by L. So as per the question, both the accelerations are same. So we can write g sine theta is equal to v square by L. Now if you apply the law of conservation of energy, you can see the height lost is this much, because of which it gained the speed v. Okay, so this is L, so this part will be L cos theta, so this will be L minus L cos theta. So we can write g sine theta is equal to v square is equal to 2g into height lost. Height lost is this. Okay, students. This is by applying law of conservation of energy. So v square is equal to 2g height lost. So L gets cancelled, gg gets cancelled. So finally we are left with sine theta is equal to twice into 1 minus cos theta. So let us divide this into half angle formula. We will be reducing this to half angle. So sine theta can be written as 2 sine theta by 2 into cos theta by 2. Okay. So 2 sine theta by 2 into cos theta by 2. Whereas this 1 minus cos theta can be written as 2 sine square theta by 2. So 2 gets cancelled here. Even 1 sine theta gets cancelled here. So we are left with tan theta by 2 is equal to half. Therefore theta is equal to 2 tan inverse of half. 2 tan inverse of half. So this is the correct answer. Okay, students. Right. Then moving on to the next question. Given below are two statements. You can see statement 1 states the limiting friction of static friction, the limiting force of static friction depends on the area of contact and independent of metal. This is absolutely wrong, students, because you know that the limiting force of static friction does not depend on the area of contact, and also it depends on the nature of the surface. In other words, it will depend on the material. Then coming to the statement 2, the limiting force of kinetic friction is independent of the area of contact and depends on material. This is absolutely true. This is what we require actually. So statement 1 is true, false, and 2 is true. So 1 is incorrect and 2 is correct. So correct option will be 2. Okay, students? Right. Moving on to the next question. Question number 13. A bullet is fired into a fixed target and loses 1/3 of its velocity after traveling 4 cm. It penetrates further d into 10 power minus 2 meter before coming to rest. The value of d is. So students, here the underlying assumption is the resistance offered by the target, okay, to the movement of the bullet is constant. Here by resistance we mean the retarding force offered by the target to the bullet. So that means acceleration, or that is retardation, is also constant. So that means here the underlying assumption will be retardation is constant. Retardation means negative acceleration. So let us say that the bullet has an initial velocity u, and as it moves a distance, certain distance, let us say s1, it loses certain fraction of velocity, and let us say it has become, the velocity has become u by n, where n is greater than 1 of course. Okay, so we can have the formula v square equal to u square plus 2as. Using this formula we can write u square by n square is equal to u square minus 2, a is constant, okay, so into s1. So therefore I can write u square into 1 minus 1 by n square is equal to 2a s1. So this is equation 1. So again it is now traveling with velocity u by n, and it has to come to rest. So final velocity becomes 0. Let us say it further penetrates a distance s2. Okay. So again using the same formula, this formula, we can write final velocity is equal to initial velocity square minus 2a into s2. So therefore u square by n square is equal to 2a s2. This is equation 2. Okay. So if we divide equation, since we require s2, so we are going to divide equation 2 by 1. So u square gets cancelled here, and even n square will get cancelled. 1 by n square will get cancelled. So we have 1 upon n square minus 1 here is equal to s2 by s1. Therefore s2 is equal to s1 by n square minus 1. So you can treat this as a formula, students. Okay. In our case it is 4 cm, and this is 1/3. So this will be 3 square minus 1. So 4 4 by 8 loses 1/3. Sorry, I'm sorry, students. Since it loses 1/3, so the remaining will be 2/3, isn't it? So n is 2 by 3. Sorry, students. So initial velocity is u, and the final velocity will be initial velocity minus 1/3 of velocity. So 2u by 3. So our n will be 3 by 2 here. You can see. You can write this as u upon 3 by 2. So this will be 3 by 2 minus 1. 3 by 2 whole square minus 1. So which is equal to 4 cm into 4 by 9 minus 1, that is 8. 8 and 9 minus 4, that is 5. Okay, students. So this is 16 by 5, that is 3.2 cm. So 3.2 cm is the correct answer. Okay, students. Then moving to the next question. So all questions are done. So that's all, students, in this video. Thank you so much for watching my channel.